Hello, happy Sunday evening. Let's see. Yeah, for exercise, I guess we can use some martial arts. I guess. Yeah. Okay. So this rod, yeah, I think it's good for strengthening the fingers, right? Yeah. Right. Okay. I learned how to do this from Tibetan Buddhists when I was in Madison, Wisconsin. Okay, so very exotic. Yeah. Woo! Okay. Uh, yeah. Yeah. Right. So yeah. Ah, ah, wah. Behind the neck, behind the neck, under the leg, under the leg, the other way, right? Behind the back, the other way, above head, right? Yeah. Ah, cha, right? Okay. Ooh. Yeah, it's fun stuff. Okay, let's take 5 minutes break, okay? Yeah. Right. Good enough exercise. Right. Okay. Ah, well, uh, yeah, happy Sunday evening, everybody. Um, yeah, let me grab some Coke. Coke Zero. Actually, I'm gonna grab Fanta. Uh, yeah, Coke Zero. Yeah, I took a long nap. I woke up, rolled out of my bed like 9 o'clock p.m. Sunday evening, and yeah, I didn't write the economics paper because I seriously need some break. But we have very good result here, right? Yeah, Sam Walton principle, we proved it. Some vindication for him, right? Mr. Sam Walton. We call it Walmart principle. Yeah, Walmart principle. So that was good, right? God gave us break so that the it was factorable, right? That was very nice. I didn't expect that. No, no. First time, never. In my opinion, I mean, as far as I recall, it was first time we actually did this in a general case. About 2 years ago, yeah, we did. We plugged in some numbers, right? But when it comes to generalization, using A and B as a x-intercept, y-intercept, I think it's first time. I'm not sure because I don't remember factoring like that. Okay, so yeah, so but that one on the whiteboard, I write it down in the paper. Uh, maybe tomorrow. I don't know, but eventually it will be written down next week, at some point. So before I went to bed, uh, I think I continued to watch this Ruan Atkins, the Mr. Bean. I think so. And I ate double quarter pounder. There, yeah, no cheese, no mayonnaise. Okay, and also triple cheeseburger. Oh, that was good. McDonald's. That was very good. Yeah, I liked it. Mm. Triple cheeseburger, huh? Yeah, he was good with American cheese, of course. He was very good. This Coke Zero, zero sugar, right? Yeah. Yeah. So after I woke up, I had Sunny D, the orange juice, kinda, right? Oh, that was good too. Yeah. Okay. Uh, yeah. So we did enough mathematics. I guess we can take a break from mathematics and also economics, right? Yeah. Let's take a break from it. Okay. Yeah. Yeah. So Mr. Bean series, Mr. Rowan Atkins, he's kind of like Middle Eastern origin, I think. I mean, he has very thick eyebrows, brown skin, right? Yeah, he's Middle Eastern descent. But all his other casts, they're like white people, British, right? Yeah. So when he interacts with those actors in the storyline, okay, yeah, he's very racially conscious. Okay, he basically it's kind of love and hate relationship between Middle Eastern Arab origin, Mr. Rowan Atkins, and white people in Great Britain. Okay, yeah, very racially conscious, kind of love and hate relationship, little bit, right? Yeah, great comedy. Yeah. Uh, yeah, I'm just blank because just woke up from long nap, so my brain is just comfortably blank, empty. Yeah, we are doing very good job here. Okay, economics paper. Yeah, yeah, it's a gamble. Also, entertainment. Like a lot of people with disposable income, they invest in like stock market, right? Yeah, it's a gamble and it's an entertainment. Yeah, like price going up and down, right? It's like a video game basically. Okay. Yeah, so we are doing economics paper here, and it's a gamble, and also it's an entertainment. It's an investment too. Yeah, because even if this economics paper and other papers, if let's say it never get to see the light of day, all right, maybe you just die with me. I'm okay with that. Okay, why? Because I learned a lot, and I had a lot of fun writing those papers. No harm done. I don't think it's waste of time, even if it doesn't become anything. All those papers I write, because well, hey, I had fun and I stayed out of trouble, kept myself busy. I call that a win. I call that a success. Hmm? Yeah, entertainment. Yeah. Hmm. Yeah. But I think we have a good chance. I mean, these papers. I think there's good chance that those papers will be mainstream one day. Okay, at least famous. Most likely mainstream one day. Okay, it may happen during my lifetime or after long I'm gone. That I don't know. All right, but so we are doing humanology here. Okay, so it's tripartite balancing between work, play, and rest. Okay, that way we can live long, right? So work, play, and rest. So that's why we keep pace. We don't overwork. No, we do our share of job, be in mathematics, science, right? And after that, we play, we rest, right? But we do so on a regular basis, right? Yeah. Mhm. Yeah. Yeah. Hmm. Yeah. Hmm. So I woke up like 9 o'clock p.m. and then I look at the news actually, okay, in a long time. Yeah, being news, and I did not like what I saw. There's all these crimes, right? Horrible, horrible. Eh, Too much negativity. Mm, yeah. Hmm. Yeah. So crime prevention is this, okay? Yeah, we gotta do martial arts. We gotta learn martial arts, okay? So, yeah, I mean, I practice martial arts like here, also on camera and also off camera, okay? Yeah, yeah, very important stuff, right? Yeah. Hmm. Because this world, yeah, well, 99% of people are nice, but 1% of people kind of strange people, right? Yeah. So we have to guard ourselves from those possibilities, right? Yeah. So, yeah. Yeah. Hmm. Well, we'll take 5 minutes break, okay? I'm just, chilling, comfortably blank. Yeah, just chilling. We worked very hard on the mathematics for economics, calculus and stuff. Next time, okay, when we do mathematics for economics, we'll deal with sigmoid function, its derivative, pseudo Gaussian curve, bell curve. Okay, and we also go back. We integrate pseudo Gaussian curve, integration by parts. Okay, I looked at it. Okay, integration by parts, which is not that difficult. Okay, I worked it out in my pencil and paper about a month ago. Okay, so and as an exercise, it's good stuff. Okay, integration by parts. I think it's more like integration by substitution, actually. All right. I think it's integration by substitution. Good stuff. Okay. Yeah. It's fun. So we'll do that. Okay. And so that's what's ahead. Probably tomorrow or a couple of days later. Right. Yeah. We'll do that. So yeah. So for us doing mathematics is playing video game. Okay. Yeah. It's a lot of people ask me, yeah, why do you do mathematics? Okay, what a waste of time. But it's like playing video games, basically. Okay, it's fun, right? Yeah, yeah, it's not that different. Well, investing in Bitcoin, Bitcoin, yeah, it's like gambling, right? People do that for fun, I guess. Yeah, Bitcoin, I don't think there's intrinsic value to it. Maybe there is. I don't know, uh, but I understand why some people do it. Okay, it's like playing video game, right? Gamble, entertainment. I don't understand. Okay, so we're doing mathematics. It's pretty much the same thing. It's gambling, investment, and also entertainment. Okay, so yeah. Okay, we'll take 5 minutes break. And if nothing comes to my mind, I don't have any stories to tell, we may as well just keep doing mathematics, okay? Sigmoid function, but I don't quite feel like doing it, okay? Because we had enough mathematics done already over the weekend, right? I'd rather take a break, okay? So, all right, we'll take 5 minutes break, okay? So, all right. Okay, well, let me grab some juice. Well, Diet Coke, uh, it doesn't have any nutritional value, right? Yeah, so apple juice. Yeah. What state is this from? Georgia. Apple juice from Georgia found its way to Alaska, huh? Okay. Yeah. No sugar added. I like that. Okay. Yeah, I drank too much like earlier today, so that's why I'm not drinking alcohol. Yeah. So, oh, it's good. Oh, I love apple juice. Good stuff. Vitamin C. Mm, yeah. Back in the days, these people who came to Alaska mining the gold miners, stampeders, right? They have many nicknames. Okay, so many of them suffer from scurvy, this vitamin C deficiency. Okay, some people didn't because some people ate these wild berries. Okay, so they didn't get scurvy. Okay, so yeah, Alaska have wild berries, but from what I've read and feel strong, right? Alaskan history. Uh, a lot of people during the winter, there are no berries in the winter, right? So they ate bacons and beans, I think. Okay. So yeah, during the winter. Okay. So yeah, that's why they got scurvy. Okay. No vitamin C. I'm not sure if that's what they ate. Beans, don't they have some vitamins? Maybe they ate bread. I don't know. Okay. But they suffer from scurvy, the vitamin C deficiency. Okay. So yeah. 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 Yeah, just comfortably blank. Yeah. Well, let's see if there are any whiteboards we can erase. Okay, I am too blank now. All right. Yeah, probability. Yeah, this is easy stuff, so I think we can erase this. All right. Yeah. Some small note I wrote down there that I just erased. Importance of ethics in hard times. Yeah, so when we go through some difficult times like pandemic or war or whatever, right? Yeah, those are testing times, and in difficult times, testing times, we can tell who's strong, who's weak. Okay, strong people, they do not compromise their ethics, moral compass, right? But weak people, yeah, they kind of commit some unethical, immoral conducts during the difficult times. Okay, so that was that. Okay, uh, I guess we can do some mathematics. I'm sorry, I just don't have anything else to do. Okay, so okay, please bear with me. Okay, uh, Zigmund function. Okay, 2.5, 1, Alright, so this y is equal to, alright? Yeah. So if you differentiate it, okay? Gosh. Differentiation y prime is equal to, okay? Now, we want to go backward, okay? We want to integrate this guy to make this guy. Okay, how do we do that? It's that's is it's called integration by substitution, I think. Okay, so let's say u is equal to 1 plus e to the minus x. Okay, so this is like well, whatever. Then du is equal to minus e to the minus x dx, right? Okay, so this is like minus 1 over u squared. Okay, so um so integration, okay, integration minus 1 over 1 plus e to the minus x squared dx is equal to, gosh, I forgot how to do this. Hmm. Well, I'm not good at integration, really. Uh, I wrote this down somewhere in my notes and I have to look it up. Okay, so let me see. Let me see. Oh, it's right here. Okay, okay. I made a mistake. Okay, got it. Yeah, the chain rule, right? Yeah, I forgot that part. Okay. There we go. We got it. Right? Yeah. Whew. That's integration by substitution. Okay. Okay. Now, uh, so we have y and y prime. Okay. Y prime. Okay. We can simplify this. Okay. This is like if we multiply e to the x. All right. Why do we use Euler's number e? Well, it's for the sake of simplicity because e to the x, if we differentiate it, becomes e to the x itself. Okay, it's for ease of calculation, differentiation. That's all it is. Okay. Yeah, very convenient number. That's kind of definitional property of e is that when you differentiate itself, e to the x, it becomes itself. Okay, so yeah. So what's the slope here, tangent line, when x is zero? 1/4. Okay, yeah. Okay, 1/4. So basically, this y prime looks like this. Okay, it's like bell curve. It goes like this. Very small bell curve, basically. Okay, all right. Just 0.25. Okay. hmm And we need to make some modification to make it to our transactional demand curve. Okay, so yeah, because we are trying to do population model, so this guy's bell curve population model. Okay, so we're gonna shift it to the right. Okay, yeah. Well, yes. Yeah. Say y prime is equal to e to the x minus, let's pick a number. Let's say 5. Okay. Plus 2 plus e to the 5 minus x. Okay. And gosh, it becomes really complex, huh? Mm, yeah, it would be like this. There's 5, and there's our new bell curve. Okay. But I think it will help us to keep it as simple as possible. So this guy is like e to the minus x over 1 plus e to the minus x squared. Okay, so okay. We'll talk about this later, okay? But for now, we'll just say uh integral, okay, integral from x to positive infinity, right? Of that this guy e to the minus x over 1 plus e to the minus x squared dx. Okay. Uh, which is okay. when goes to infinity, it's 1, right? So it becomes like 1 minus, uh, I think that's what it is. When x goes to infinity, okay, you become 1, right? So yeah, it makes sense. Hmm. So minus 1 over 1 plus e to the minus x. That's like reflection along x-axis. Okay, so you will be like, right? And we are adding 1 here. Okay, so shift up 1. Okay, so you will be like this. Okay, this is zero point 0.5, and here is 1, minus 1, minus zero point 0.5. Okay, so, and that's the transactional demand curve that we want. Okay, and it's in shape. Okay, spot check. When x is 0, yeah, 0.5. When x go to infinity, 0. X go to minus infinity, 1. Okay, it works. And in order to shift to the right, okay, what we gotta do is this, all right? Instead of x, we put x minus a. Okay, so our transactional demand curve, let's call it d, okay, is equal to 1 minus 1 over 1 plus e to the minus x minus a. That's open and close pattern. Okay, so this a minus x. Okay, so it will be like this. Okay, and there's your a. All right. So yeah, I'm sorry about being lousy. Okay, but yeah. Okay, good. You got it. Okay. Fourth time. I've never done this before. Okay, so yeah, good. You got something done here. Okay, very good. We'll take 5 minutes break. Okay. I bring this close to you so that in case you want to see it. Okay. I'm not sure if you ever anybody would want to see this. Okay. But if you like mathematics, just in case you want to understand what's going on here, okay? And we got it. This is it. This is our boy, okay? Yeah, yeah, I'm pretty satisfied about this. Okay, so yeah, very good, excellent. Okay, we'll take 5 minutes break. Excellent. Here we go. I grab my cell phone and take a picture of this. Okay. So we got some job done here, which is great. Great. Yeah. First time. Yeah. Okay. Let's take a picture of this baby. Let's take a picture of this baby. Okay. So very good. Yeah, I'm very happy about this. Very satisfactory. Yeah. So our transactional demand curve, right, using which is integration of pseudo Gaussian curve. Okay. Yeah. Using the so our newest transactional demand curve, it has same shape as our old model Z curve, right? It's not S curve, that's sigmoid function, right? We have Z curve. It's flipped, right? And it's quite surprising, right? Because when we use the flat Earth hypothesis, where there are same number of all these economic classes, okay, and our conclusion was that it was Z curve, Z shape, right? And we have that even using pseudo Gaussian population model, which is more realistic. We still have Z curve, okay, which is quite surprising a little bit. Okay, so yeah, we found gold, metaphysical gold in Alaska. That's not why I came to Alaska, by the way, right? I came to Alaska to relax, kind of to get away from it all, right? Like many people in Alaska, right? Yeah, uh, wherever you are, what country or what state in America, or wherever you are, I'm sure it's a great place, okay? But I can only speak for Alaska because that's where I'm at, all right? So Alaskans, we kind of understand each other, right? Because we came from all different places, and we came to Alaska pretty much for the same reason, okay? Freedom, independence, right? To get away from it all. So Alaska is very close knit community. There are not that many people. Like it's almost like everybody knows everybody, kinda. Okay. Yeah. So yeah, it's a very nice place to live. So Alaska is like its own country, kinda. Okay, we have our own culture and very multi-ethnic. All right. So and we have the kind of similar sentiment, common denominator. We love freedom, independence. So uh, I'm kind of new to Alaska compared to others. So when I was doing Alaska State Senate race election last year, I met some Alaskans. Okay, they did not like some of them did not like my ideas. Okay, because uh several. Okay, so they voiced some objections, and I listened. Okay, so basically, I'm kind of like pro industry, pro development. So when it comes to the Pebble Mine project in Bristol Bay, they wanted to build a mining company, and it did not pass because Alaskans they wanted to protect salmon and mining operation. It can hurt salmon population. Okay, so I'm pro Pebble Mine. Okay, so but many Alaskans did not like that project, so it didn't pass. So those Alaskans, in their opinion, is this okay? We don't have to follow Law 48, pro development, industrialization of Alaska. Okay, they did not want to go down the same track as lower 48. They wanted to preserve Alaska's clean air, clean water, nature. So I can understand. I do. Okay. But it took me a while to understand that. But the reason why I'm pro development is that children of Alaska, okay, what I want is to give them good jobs, okay, good education, good career. They're children of my friends, also grandchildren of my friends, because I don't have any kids, obviously. And I'm not going to, okay, I don't want to. But I do care about children of Alaska, okay, so, but hey, it's up to the people, right? Yeah. And I'm not a politician, okay. Although I intend to keep running, but yeah, so anyways. Yeah, I guess I'm kind of addicted to mathematics, right? Just like some people are addicted to like stock market investment, right? It's kind of like gambling addiction, kinda. So mathematics, yeah, I guess it could be addictive, but I think it's a good addiction, okay? So it's not unhealthy to do mathematics, and we are not losing any money, right? And people with disposable income, they do gamble, right? It's entertainment, right? Yeah. They may lose money, but well, they have disposable income anyway. So it's for the entertainment, right? When we do mathematics, we lose time and money value of time. Yeah, I guess. But would I be doing something that makes money if I'm not doing mathematics? I don't think so. Okay. What would I be doing if I'm not doing mathematics? I'd be watching television. I mean, I don't have cable TV, so I'll be watching most likely in the Amazon Prime, buy some movies and watch it, right? Eh, they will cost money, okay? But when we do mathematics, we are not losing any money, at least. We are losing time, but that's good expenditure of time, but we are having fun, okay? So, yeah, I think we found gold here, metaphysical gold, okay? The Z curve, okay? God is definitely with us, all right? Holy Spirit, yeah, Emmanuel, God with us, okay? So, and God, thank you. I'm very grateful. Okay, and I thank you too. Okay, so um, we found gold here. Okay, surprisingly, even after we used the kind of pseudo Gaussian demographics, okay, uh, it still ends up being a Z curve. That's something really cool. Okay, yeah. Our next step to find profit maximization point. My guess, you'll be in the middle point. That'll be my guess. Okay, profit maximization point. I think it will have to be the middle point. Okay, and we shall see. Uh, so we have to multiply by x, right, on that transactional demand curve, right, to have this rectangle. And after that, we have to differentiate it, right, and find zero. May I? Because I got nothing else going on. Okay. No stories to tell come to my mind, so we may as well see what it looks like. Okay, we take 5 minutes break. Okay, and what we gotta do is multiply by x, right? And just differentiate it, and then equalize to zero, and solve that equation. And I'm not even sure if I'm capable of doing that. It'll be a challenge, all right? But we have a graphing calculator, all right? So I'm kind of curious about it. Okay, so let's do it. Okay, we take 5 minutes break and we grab another whiteboard and then try to find the profit maximization, revenue maximization point. Okay, that'll be an interesting project. Mhm. Okay, my guess is it'll be middle point A. Okay, that'll be my guess, but we'll see. Okay, how interesting. Okay, we take 5 minutes and we go ahead and do it. Okay, so okay, very good. Okay. Let's find the whiteboard. Whiteboard to erase. Alright. Hopefully it won't be too difficult. Yeah, we're just using chain rule, basically. Okay. Alright. So our revenue function will be the transactional demand curve minus multiplied by x. Alright. Our revenue function, okay? Okay? So, we're going to differentiate it, okay? So, to find the maximum point. Well, first of all, I don't even know what this curve would look like. Will there be local maximum or not? I don't know. Well, I can graph this in my graphing calculator, but let's do that, okay? Let me grab my graphing calculator, okay? So, okay. Yeah, let's draw this. Doesn't quite seem to have local maximum, but I don't know. Okay, so we put we use 5 for a value of a. Okay, so it doesn't really. Whatever. How do I go back to the equation? y is equal to, I have to do this again. Okay, so uh, how do I zoom out this thing? It does have local maximum. Okay, okay. It when x is 4, I thought that when you should have local maximum when x is 5. Okay, so we'll see. Okay, so okay, we'll differentiate later. Okay, so for now, let's play with numbers. Okay, so when x is 5, e to the 0. Hmm? When x is 4, e is like 2.7, right? So okay, okay, but that's strange. It's bigger than that. Okay, so that's not quite what I expected, but that's fine. From what I've seen, um, well, whatever. When x is zero, yeah, the graph is zero. Okay, so window. Uh, how interesting. Yeah, the graph looks like this according to this graphing calculator. Okay. Okay. Yeah, when x is zero, y is zero, right? Yeah. But if x go to infinity, okay. Uh, this one zeroes out, right? So infinity minus infinity is kind of become like zero. Okay, so yeah. Hmm. 'Let's go ahead and differentiate it. All right. So okay, how interesting. Well, it's like differentiation by part. Okay, so uh, 'If we differentiate this, I gotta look up. Okay, differentiation by part. I think that's what it's called. It is, okay. Product rule. I think it's called product rule. Okay, all right. Okay. All right. So plus one minus one, they will cancel out. Let's expand this. All right. What we are left with is minus. Okay. Well, e to the x, whatever, or e to the minus x, this exponential curve. So it's never zero. So if we put this guy as zero, yeah, we can safely get it away. Okay. Then what we have left is, and how can this possibly be zero? Did I make any mistake somewhere? I think I made some mistake somewhere. All right. Oh, oops. It should be minus two here, huh? But still, I mean, how can this possibly be zero? Hey, because x should be about like four or something. Four, yeah, it's not five. It should be like four, which is strange. Okay, so well, that's kind of one of my principle too. Okay, and less than half. Okay, profit maximization point. So, but I don't quite see it. With this x is positive, and 1 plus e to the whatever, that's positive number, so you can cancel out this plus 1 here. I'm wondering if I made another mistake. Ah, I did. This is minus 1. Okay, let's redo this. Gosh. Okay. We multiply by this guy. Okay, so wow, what an equation. We'll take 5 minutes break, okay? And we'll grab another whiteboard and we'll try to solve this, okay? I don't know how to solve this, alright? But we'll take a look, okay? Okay? And we can, and we'll say e to the 5 minus x, we call it y to simplify, okay? And we'll expand, go ahead and expand this. How interesting. It's algebra, okay? Yeah, how interesting. Okay, we'll take 5 minutes, okay? Uh, how interesting. Yeah. Okay. We'll replace this whiteboard. Yeah. We'll erase this guy, okay? Yeah, I really don't like erasing stuff, but because we solve this, and this is concrete example with numbers, and we solve more general case, right? So it's safe to erase this because in the paper I will present only general case, okay? Because this quite simple mathematics anyway, so yeah, no concrete number necessary in the paper, okay? So all right, let's copy down our equation. R prime is equal to mm, we call it Z, okay? So then we expand this, okay? Okay. And we know this guy can never be zero. It's exponential function, okay? And it's always positive. So we can safely divide by Z, okay? So Z plus, okay? And let's plug that in, okay? So, okay? So, what we are doing here is this, okay? We are trying to find the intersection between e to the 5 minus x uh, and this line, straight line, okay? So to draw diagram, well, we need some room here, so, okay? e to the minus x goes like that. E to the 5 minus x, well, we shift by 5, right? So when x is 0, here you have e to the fifth, which is like 3 to the fifth, that's like 3 to the fourth. Okay, 9 times 9, 81, okay. 243. About 200, okay? Okay, so that's this guy. Y is equal to x minus 1. That's like your minus 1 here, okay? This is the point where this becomes 0. Okay? And what is that point? I don't know. Let's play with it, okay? So 5 minus x. Alright? I don't know how to solve this equation, okay? So, but according to this graph, this is slightly less than 4. Like 3.9, something like that, okay? So, let's see what, when x is 4, okay? So, then you have e, which is about 2.7, okay? When this is 4, 4 minus 1, 3, okay? So, yeah. It makes sense when this should be slightly less than 4. Okay, okay. Yeah. Yeah. I think I can drink a while, drink a little. Okay, so this is quite surprising. It's still Walmart principle a little bit because the maximization point happens before middle point, which is quite surprising to me. Okay, yeah. Uh, I don't think there's general solution for this. Probably you have to use like Newton's method or something like that. Okay, to find solution, exact solution for this x. Can this calculator, graphing calculator, can it solve an equation? I'm not sure. So, Where's equal? So I drew this graph of this guy, y is equal to this guy, okay, and I'm doing some tracing. X is about like 3.9, okay, about like 3.2 something, okay. I'm 3.92 about that, okay, so it's about 3.9, okay, okay. So, well, that's when X, this guy is 5, but in general, when this guy is A, uh, then X is some number slightly less than A. That's our working hypothesis. But how do you prove that? Uh, uh, some different approaches. Okay, so um, okay, we want to prove this. Okay, let's say this function is fx. Okay, and if we plug in, so our hypothesis is this solution x that's about 4. Okay, which is less than 5. Okay, so that's what we need to find. Okay, so f 5 is equal to e plus 1 minus 5. Okay, f of 4. I'm sorry. Let me look at this function. Okay. And f of 3, 2.7 times 2.7. What is that? About 7, okay? So, okay. Then, the point where this becomes 0 will be between 3 and 4, because 7 is positive, 4 is negative, I mean, minus 0.3. So it's like 3.7, I mean, 3.9. Okay, that's where it becomes 0. Okay, because you're crossing the 0 boundary here. Okay, negative and positive. Okay, so, okay. So that'll be our approach. Okay, we're getting it. How do you generalize this thing? Um, instead of 5, we put a there, right? Yeah, and plug in like a instead of x. I mean, yeah. It does get messy, okay, but I think we're getting quite close here. Okay, so okay, we'll take 5 minutes break, okay, and we'll have to grab another whiteboard and get to the bottom of this. Okay, so my guess is this. Okay, the solution, the maximize profit max revenue maximization point, I think it'll happen like around a minus 1. That's working hypothesis. Okay, and let's see whether that's true or not. We're gonna have to grab another whiteboard. Okay, so okay, we'll take 5 minutes break. Okay. How interesting. Okay, there we go. Alright. Whew. Yeah, we are crunching numbers basically, number cruncher, right? Yeah. Okay, let's grab another whiteboard. I don't know which one I should erase. Oh boy. Breaks my heart. We're gonna have to erase this guy, okay? Because it's pretty, right? And it's something very simple. Uh, what is this about? I don't know, alright? It's we have to erase this, alright? Yeah. It's very pretty. Yeah, we found this formula a while ago. But I guess we're gonna have to erase it, alright? Again, breaks my heart, okay? But we have to move on. Hey, breaks my heart. But it's all recorded, right? In the humanology series. So yeah, it's already recorded. So no harm done. Okay, so yeah. It really hurts my feelings. But hey, it's business decision. We have to do it. Okay, so let's take a break. Okay, so business decision, right? Yeah, it's in jurisprudence, the corporate law. Okay, uh, sometimes we have to make tough choices, right? Yeah, we may in a company, right? We may work on a project. Sometimes after all the effort is done, it's a sunk cost. It's accounting term. Yeah, sometimes we have to abandon project, although we spend time and money for it. Okay, to move on, right? Tough decision. So that's what we did. Okay, so okay, FX, right? We're generalizing it. Okay, uh, instead of five, we put some positive constant a. Okay, okay. First, FA. Okay. Second, FA minus one. Third, FA minus two. Okay. What if f of a minus n? Okay. For now, let's say a is of quite a big number, but it's finite. Okay. So as n go to infinity, okay, this will go to infinity because a is a finite number. Okay. So you become positive. Okay. So at some point, this, because a is a quite big number, more than two. Okay. They are all negative numbers, but at some point it will become positive number. Okay. And some number between negative and positive number, it will be somewhere there, it will be zero. Okay. So this guy is less than zero, this guy is more than zero. So somewhere in between. Okay. So that's the proof here. All right. Yeah, it is Walmart theorem, Walmart principle. Okay. The profit maximization point happened before less than A. A is the middle point in the transition demand curve. Okay, so yeah, that's the proof. Okay, so okay, good enough. Whew, we got it. Cheers. Yeah. So what does this A mean? That's the point where in the bell curve, pseudo Gaussian curve, that's the middle point where the this is where A is. Hmm? And that's the money where that's middle income. In America, say $50,000 per year. So A is like $50,000 disposable income or salary. Okay, that's bigger than two, right? And who makes $2 per year? Well, in foreign currency, yeah, sure, but in their currency, yeah, $2 means big deal because that's what they are making. If that's what they are making per year, well, back in the days in America, $2 was worth like $200. Okay, yeah, so across time and space, $2 per year, it can be something big. Yeah. Today in some foreign countries, or back in the days in America, yeah, yeah, $2 was a lot of money. You could buy $2 100 years ago, probably were like $2,000 or $200, something like that. Okay, so yeah, there's some calculator, current, okay, inflation going back, okay, online. Yeah, there's some calculator over that. Okay, so inflation calculator. Okay, based on like compound interest formula. Okay, so, okay, we got it. We got it. Okay. And So this is pseudo Gaussian curve right here, okay? And our z curve, it goes like this, okay? So this A, that's like inflection point, okay? Yeah. And we're gonna have to prove that, okay? Yeah, it will be second derivative and it becomes zero, okay? Yeah. I will do that sometime later, okay? We can do it now or after 5 minutes, right? Let's do it. Uh, and for simplicity, we'll just use this. Okay, so y was 1 plus e to the x, right? Because we flip it, right? And y prime is trying to save some space here. Okay, so y2 prime is well. Too much calculus. When ex is zero, yeah, that's the inflection point. Okay, so Yeah, we got it. Yeah. Boy, it's good that I pay attention on those mathematics classes. Okay, yeah, we got the inspiration point there. Okay, so Hi. We got it. So over next week or next 2 weeks, I gotta write this all down in this economics paper. Okay, yeah, it may very well over. Well, so far, economics paper 50 pages. Okay, and it may become about 100 pages. Okay, because we discovered some good stuff here. Okay, yeah, but hard job is done. Brain job. Okay, what's left? Brain job. Okay, I have to type this all down. Okay, doing all these diagrams and whatnot. Okay. Oh boy. Mountain. All right. But Jesus said, if you have a faith at the size of mustard seed, you can move the mountain. All right. Yeah. We will. I'll write this all down. It will take a couple of weeks. Okay, to write down what we discovered over a couple of days this weekend. All right. We discovered a lot. Yeah. Cheers. Great. Yeah. So FA, when A is big, is like average American's income level per year, okay, like $50,000. That's a lot bigger than two, okay. So two minus 50,000, yeah, less than zero, okay. But somewhere as n goes to infinity, e to the n go to infinity, n goes to infinity, okay, minus a $50,000, okay, that's bigger than zero. So somewhere in between, okay, yeah, it will become zero, okay. So that number is a minus k, okay, which is less than a. That's Walmart principle. Sam Walton theorem, okay. So yeah, a is the halfway in the middle point, okay. But profit maximization point, surprisingly, it happens less than a, okay. Yeah, it's not very obvious. It's not very intuitive, and but so yeah, again, Mr. Sam Walton, his business method is vindicated, justified, and proven to be correct. Okay, you lower the price in order to maximize the profit, even assuming bell curve. When it is pyramidal shape, food chain, food pyramid, then we know, yeah, it's the profit maximization point happens at not. have the point like a over 2, but a over 3. That was easy proof compared to this guy. Huh? Yeah. Yeah. We got it. Right? Yeah. Yeah. Yeah, I'm looking at the whiteboard over there. Kind of bonding period, right? We just gave birth to this mathematical baby. I'm just looking at it, hugging it. Okay, so uh, oh well, let's snap out of it. Whew. So I cannot help going over it. Okay, let's just take a look at this guy. So, so the starting point was sigmoid function, right? We integrate it. To get this. She's pseudo Gaussian curve, right? So sigmoid function. We start with sigmoid function, and we differentiate it. So sigmoid function, logistic curve, we differentiate it to get this pseudo Gaussian curve, okay? And then we're integrating it from x to infinity, okay? And then we get z curve, which is flip of sigmoid function, okay? Which is s curve, okay? Yeah, we integrate it, we get z curve. Why? Because as x increases, the area decreases, okay? So that's why it gets flipped, okay? Yeah, integral from x to infinity. As x increases, the area decreases, okay? That's why it gets flipped, right? So, and then we parallel transfer to positive x direction by a, okay? So that's why we have that. So that's our transition demand curve, z curve, okay? All right, okay, makes sense. Okay. Let's take 5 minutes break, okay? So yeah, I just wanted to make sure this is correct, and it seems to be correct. Okay, so good. Our job is done here. Okay, we came a long way. It will take a couple of weeks for me to write this all down. I have to do all these diagrams, right? All these mathematical equations and whatnot. Okay, yeah. So, but hard part is done. Okay, the only thing left is for me to write this all down. Okay, so which is kind of mechanical job, right? Yeah, but brain job is done. What's left is brain job, which is very important. Okay, so yeah, it'll take a couple of weeks to write this all down. Right? Yeah, but I'll do it slowly. It'll take a couple of weeks. Okay, it'll take 5 minutes break. All right? Wow. I'm glad we did this tonight. It had to be done. All right. God gave it to us. We got it. Okay. Yeah. Okay. Okay, story time. We did our job, right? Yeah, let's have some fun. Let's relax, right? Uh, yeah. Let's congratulate ourselves, shall we? Cheers. That was tough, but we got it done. Cheers, everybody. We came a long way, right? Heavy, heavy mathematics. It's not too difficult mathematics. It's just, calculus, right? At the level of undergrad in four-year college, about second semester calculus a little bit because we use e to the x, exponential function, and some, yeah, equation involving e to the x and x. Okay, so we couldn't quite solve it directly, but you can tell less than zero, more than zero. So halfway in between must be equal to zero, right? Because their function is increasing, right? We got it. Okay, so yeah, Walmart principle, Sam Walton theorem. Okay, so he was right. Okay, yeah. Story time. Okay, let's step out of all this. Okay, so when I finished my papers, last year about special general relativity disproof. Okay, yeah, special relativity disproof paper is called inertial axiom theorem, something like that. Okay, general relativity disproof paper is called something like force echelon theory, something like that. Okay, so after those papers were done, yeah, I presented this paper to my friends, my family members. Okay, and my dad said, "Yeah, hey, good work. Yeah, I appreciate your effort." Hmm? And I was very happy to be approved by my father. Okay, that's very important. Okay, yeah, approval. Also, my friends, yeah, they appreciate it and made some comments. Okay, some of my friends they disapproved, but I was just grateful that they actually read my paper for their time. Okay, I said thank you for your time to read this paper. Okay, yeah, approval, disapproval. To me, approval is important, but I appreciate their time to actually having read my paper. Okay, so whether they approve or not, I'm just grateful. So I thank them. Okay. Mhm. So yeah, my dad said, "Yeah, I hope your paper will be well received." Okay. Yeah, good work, good effort. I appreciate your effort. Okay. I was very happy. Okay. So yeah, approval by father, by colleagues, important. Okay. Yeah. Yeah. But uh, whether these papers get approval or not, I will continue to write. Why? It makes me happy. I got nothing better to do. Okay. Yeah. It's a mathematical product, papers, okay? Academic product. We enjoy producing these papers, but we don't quite depend on other people for our happiness. We are independent, okay? We just enjoy the process. Okay? That's one of my spiritual mentors, okay? He's an African American gentleman, okay? Uh, when I was in army, he was my sergeant, okay? African American gentleman. Very wise man, okay? Yeah. Some of my friends, very smart people, okay? They're older than me, okay? So, yeah, you enjoy the process, right? Yeah, don't focus too much on the outcome, okay? And, yeah, wisdom, right? Yeah. He's an African American gentleman. One of my spiritual mentors. Some other spiritual mentors of mine, they are Caucasians, Asians, African Americans, okay? I have many friends, spiritual mentors, okay? And some of them are Middle Eastern origin or Hispanics, okay? I have many different spiritual mentors, okay? Some of my friends, spiritual mentors, they said, yeah, never stop being you. Never stop being you, okay? So my friend said, when I was in the US Army, uh, because my nickname was Smiley, Smiley Lee, okay, because I always smile, okay? Yeah, don't you ever let other people make you stop smiling because they loved my smiling spirit. Yeah, don't you ever let other people make you stop smiling, okay? It was a guy, my fellow junior enlisted soldier. Uh, his age, I think he was younger than me, couple of years, okay? Very wise, okay? What was his race? I think he could have been Hispanic, okay? He could have been white or Arabic. I think he was brown skinned colored guy, okay? Maybe Hispanic, maybe mixed race, maybe Arabic, I don't know, okay? So I think he was younger than me, okay? Yeah. My army junior enlisted colleague, okay? So yeah, yeah. And my Korean spiritual mentor is a Korean gentleman older than me. He was my teacher in high school, okay? South Korea, back in 1990s, okay? He said, do something only you can do. Politics, business, yeah, any other people can do it, but do something only you can do. Okay? It took me a while to find that one thing that only I can do. Okay? It's academia. All these papers. Okay? God bless those wonderful people who give me this spiritual guidance. All right? Yeah. They're all different races. Okay? African Americans, Asians, Caucasian Americans, Arabic Americans, Hispanic Americans, all different races. Okay? I have many mentors. Yeah. So when I wrote those papers, like on in metaphysics, physics, my dad said, "Yeah, yeah, yeah, I looked at it, but yeah, I don't quite understand. It's kind of difficult kind of paper, difficult paper to understand." And I was very grateful to my dad. He actually read some couple pages of my paper, and he said it's very difficult to understand. Okay, to me, that's a compliment. His PhD, tenured professor, now professor emeritus in top one of top 10 schools. I looked it up. Okay, top 10 university in South Korea. Okay, yeah. He said my paper is difficult to understand. His PhD, tenured professor, in top 10 school, university, for your college in Seoul, South Korea, somewhere, okay? And there's great compliment for me, okay? So, and he wrote many books. He's very prominent economist in South Korea, my dad, okay? I'm very proud of my parents, okay? And I did read his book, okay? And I really liked it, okay? Great knowledge in history, world history, okay? I really liked it, okay? So, yeah, I also some erratum, okay? Some typos, yeah, I emailed to my dad, and he appreciated it, okay? And I said, Dad, about two days ago, I talked to my parents. Therefore, okay, Dad, I'm a huge fan of you. Okay, I love your writing style. I also read some couple pages of his dissertation paper that he wrote in 1970s in Ithaca, New York, where I was, when and where I was born there. Okay, yeah, Ithaca, New York, Cornell University. Okay, his English was really beautiful. Okay, so he is a very good writer in English and in Korean. Okay, so so I told my dad, Daddy, I'm a huge fan of your writing style. Okay, yeah, beautifully written. Okay, in Korean, in English. Okay, you're a great writer. Okay, he liked that. Okay, I was not making that up. Okay, I really am a huge fan of my father's writing style. Okay, he's a very good writer. Okay, my mom said, yeah, like father, like son. Okay, my mom said, hey, son, if you're a good writer, you got it from your father. Okay, I was like, oh, mommy, thank you. I'm mama's boy, papa's boy. Okay, I love that American band, Mamas and Papas too. California Dream, right? I'm blessed to have very good parents. I'm sure you have good parents too. Yeah. Yeah. And my friends, mentors, current bosses, former bosses, past colleagues, current colleagues, okay. I'm surrounded by very loving people, okay, and also very disciplinary people, okay. I'm blessed. I'm blessed. Yeah, let's count our blessings, okay. I'm sure you're blessed too, okay. Yeah. Let's count our blessings, right? So every time I write this page, kind of copy and paste, okay? On the very first page, footnote number one, thanking my parental figures like you, okay? Also my parents too, okay? Parental figures, spiritual mentors, friends, colleagues, okay? People I've ever met who told me good things. There's footnote number one. Footnote number two is about my mini bio, okay? Where I came from, where I grew up, okay? What I used to do, what I'm doing now, okay? Yeah. Former computer programmer, currently lawyer by trade, okay? Yeah. Independent scholar, secular scholar, private academic, that kind of stuff. It's just copy and paste job. First page of all these papers, okay? Honoring our parents, right? Just like good old Bible says. Mosaic, Ten Commandments, right? Mm-hmm. We'll take 5 minutes break, okay? Yeah. We came a long way, right? Yeah. It's about midnight, Sunday. Okay? But I took a long nap, so I'm not sleepy. So some story time, okay? How about something exotic as special forces? I've been there, I dropped out after 2 weeks. It was too much for me. Yeah, some stories there. Okay? Yeah. We take 5 minutes. It was very good training, okay? I enjoyed it. But It was too much for me. So I dropped out after 2 weeks. Okay, so special forces. We talk about that. Hmm? Yeah, very interesting story, right? Let's take 5 minutes, okay? All right. So we are celebrating, right? Yeah, hard job is done, right? All there is left to do is for me to, over the next couple of weeks, write this all down. That's the very tedious manual, toil and moil, but brawn kind of job. But hard job is done. Brain job is done. We got all these ideas down, right? So we are celebrating it. Okay, let me sing your song. Okay, it's the same song I sang you a couple of days ago. Okay, yeah. Song by Kansas. Love this song. Okay. Carry on my wayward son. There'll be peace when you are done. Lay your weary head to rest. Don't you cry no more. Da 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 dee da 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 da. Love this song, okay. Da 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 da. Charismatic song, okay. Let me flush out my eye. Some stuff in there. Do you know what this wayward means? I think it means like unwieldy, obstinate, kind of rebellious, resisting, kind of. Carry on my wayward son. There'll be peace when you are done. Lay your weary head to rest. Don't you cry no more. Da 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 da. I love this song. Good American rock band, Kansas. Okay, I guess they're from Kansas, kind of Midwest, right? Great musicians. Oh boy. Yeah, kind of obstinate, unwieldy, kind of like rebellious. Yeah, so carry on my wayward song. Okay. You can take a break after it's all done. Okay, yeah, we got it done, right? Oh boy, it's like undergrad level calculus, right? Uh, second semester calculus, kinda, right? Yeah. So, yeah, special forces, yeah, it's kind of elitist institution. We need elites like that, okay? Yeah, special mission, right? I couldn't do it, okay? I tried. When I was flew to Texas, okay, before we deported to Afghanistan, okay, so I did try it out, and my sergeants supported me, also my officers too. Yeah, to go to Fort Bragg, North Carolina, right? Yeah. hmm I remember one sergeant of mine, okay, I think he was Staff Sergeant E6, okay, he was our platoon sergeant. No, yeah, no, below platoon sergeant, okay, I think. Our platoon sergeant was E7, Sergeant First Class, okay. So this African American gentleman, Staff Sergeant, he told us, okay, he told me, yeah, go ahead, do it, go get it, okay? Represent us, all right. I was very grateful. I remember, okay. He was African American gentleman, okay, so. So I went to Fort Bragg, North Carolina, okay, and but after 2 weeks, I dropped out. It was 3 weeks in hell, selection class, selection course, okay, special forces. I realized I couldn't do it, okay, it was too much. But after I dropped out after 2 weeks, okay, 1 week left, they wouldn't let us go home, okay? No, you do details to support surviving selection course soldiers. We did, okay? We carried all these logs, clean after them in that training, okay? Yeah. So during that 1 week, okay, so I dropped this 3 weeks selection course. I did 2 weeks. Third week, I dropped out, so I was doing the details, meaning cleaning after them, surviving members of special forces candidates. Okay, yeah, that's what we did.